Welcome back, ladies and gentlemen. In this video, we are opening up a brand new section 6.4, and the entire discussion will be about polar coordinates. Now, the goal of this entire section coming on up is going to be able to convert points in equations from polar to rectangular coordinates and vice versa. Before we get there, the goal of this video specifically is to be able to answer the question, what are polar coordinates? And how can we relate them to rectangular coordinates, which is just basic XY ordered pairs? So let's take a look. What I want to do first and foremost is I'm not going to read this entire description, but I'm going to kind of keep it on the screen while I go over a couple of things. You can pause it and kind of read it as you want. But I want to first and foremost just kind of think about what we know about the basic XY axis, the Cartesian or the rectangular plane, if you will. So you have your typical XY axis, and we know that when you have a point out here that is X units horizontal, right, and Y units vertical, that's really all that every ordered pair ever tells us, a point X comma Y that we have. And so then when we kind of started getting a little bit deeper into our discussions of trigonometry, we started talking about things like the unit circle. And then we started to make some connections between the horizontal components or the x components and the trig functions. And of course, that connection was cosine, right? And then you started making some connections with the vertical components or y's, and that was its connection with sine. And then we had ratios like tangent being y over x or sine over cosine and things of the nature. And so when you were doing these kind of things, we were able to think about this as, hey, this is x units here, this is y units here, and then we were also to say, well, this actually forms a right triangle, and we were able to find whatever this quote-unquote hypotenuse of this reference triangle was, and we called it R, right? That's kind of the general term that we use for it is R. Well, what is R actually? Well, R in the aspect of the reference triangle, it's the hypotenuse of those reference triangles. But then you also want to think of it, well, R is actually also the radius of the circle that we are talking about, right? Whether it's the unit circle or a rendition of the unit circle, it's also the radius of that. Well, when it comes to the polar coordinate system, that R is actually the pole. It's a ray from the origin out to the polar coordinate point that we are going to be discussing. So this point here, not only did it have an x comma y, right? We also kind of knew it as having a cosine, sine. But now this pole actually has a polar coordinate that we are going to denote as r comma theta. And that r represents our radius, and that theta represents this reference angle that we have in here. Now let's kind of make some relationships between the Cartesian plane and the polar coordinate system here. So if we think about what we knew things like cosine of theta was equal to x over r. And then we said sine of theta was equal to y over r. And things of the nature like that. Well, then if you also kind of think about it, we also knew that x squared plus y squared equaled r squared. That's our basic Pythagorean theorem. And so then if that's the case, we can kind of start making some more connections based on all of these guys. And you're going to basically be able to say, well, what if I multiplied by r on both sides over here? Well, what would I get? I'd get that x is equal to r times the cosine of theta. And so now that x coordinate actually has a relationship to the radius and the cosine of the direction angle. Well, I could do the exact same thing for y and get that y equals r times the sine of theta. So these are going to be huge equations for us as we continue to go on. And then we can kind of continue to keep thinking about what we know about our about our Pythagorean theorem and the connection between x, y, and r as well too. So hopefully that kind of showed and shed a little bit of light onto what the polar coordinate system really was, its connection to the Cartesian plane. Really what I want us to take away is that the polar coordinate system utilizes these polar coordinates right here. And in our next video, we are going to look at plotting polar coordinates in r, theta.